We have previously tried out what I think are the two most popular options to replace noisy old SCSI drives, the Blue SCSI and Zulu SCSI. Those two options are fast enough for many vintage machines, but not all. In today's video we are going to build and try out a faster option to run an SD card as a SCSI drive. We are also going to restore and explore matching IBM, the mighty PS2 Model 95A. The Model 95 is the last and the fastest IBM PS2. There were two variants of the 95. The 95 XP on the left here, which we have repaired, restored and overclocked in other videos. And then we've got the 95A on the right here, which we are going to restore today. It's quite easy to spot the difference. The XP has the operator panel on the left, whereas the later, and in some cases faster, 95A has the operator panel to the right. Otherwise the front is pretty much identical. And at the back too, it's quite easy to spot the difference. The 95 XP only has one serial and one parallel port, whereas the 95A has two parallel and two serial ports. And the case is also clearly different. This machine is pretty rough. The front panel is held in place with some sticky tape, and it has a lot of scuffs and scratches all over the case. And overall it's pretty grimy. So let's get inside and see if we can make it nice again. And the front panel, of course, is missing some tabs, since it's held down with some sticky tape. And sure enough, both tabs are missing. With the front panel off, we can go ahead and remove the side panel. Holy crap, it's even worse inside. Ew. I've had this machine for a while, so I had forgotten how rough it was. So this foam pad here is all moldy, and we've got a bunch of rust here. And same thing inside here. This machine is pretty rough, and it only came with one card, some sort of VGA card. Now I may actually have snatched the SCSI controller to try out some other machine. It's been a couple of years, so I don't remember. And sure enough, it's a regular IBM SVGA card. Very basic card, so I'll see if I can find something better in my stash and replace it. To get further inside, we need to push on these two tabs here and pull the front bezel off. And apparently I have stashed some parts here. Okay, that was just the speaker. Front bezel for the CD-ROM drive, which unfortunately I think is the wrong bezel. But I think I have a printed one that we can use instead. And then we have what I think is part of the lock. Now this is great news. These are the broken off tabs from the front panel, so we can glue them back on. Then we have no less than 3 hard drives, which we obviously aren't going to use. Then we have a CD-ROM drive here that is pretty badly stuck. Actually, it's so badly stuck I can't pull that thing out. So we're gonna have to try to push it out from the back. I'm gonna have to use a bit more force than I would like to. Wow, that thing is really jammed in here. Okay, I finally managed to get it out. And apparently it's installed with AT rails, so that is probably why it was so jammed. I think I still have some printed rails we can use to install it. I'm gonna go for a complete disassembly here. So we need to remove the front hinge on the power supply. And with the power supply tilted out, I think we can pull it forward to remove it from the case. This thing is massive. And very rusty too. This drive looks like it could be one of the original drives from this machine. These two are later upgrades. These are actually pretty good, if it's not worn out of course. They're pretty fast and not that noisy. Well, at least when they were new. And then we have the most important part of this machine. And this is of course the reason why I bought this rust bucket. The CPU didn't come installed on the motherboard in these machines. Instead, it came on a CPU complex like this. So if you wanted to upgrade your machine, you could just buy one of these cards. And this card here is a Type 4Y. It's the best and the fastest option that was available for the PS2 95. So if I'm gonna have to clean up some rust in this machine, this card here is going to be worth it. This machine also came with this intrusion alarm here. The XP we restored didn't have one of these. By the way, I am skipping some minor steps in this restoration, because we have done an in-depth restoration of the XP machine. Actually, the whole disassembly was pretty much identical to the 95 XP. So I just skipped ahead here, and now I have a big pile of rusty, pretty grimy parts. So I guess I'll be spending a few hours cleaning all this stuff up now. But first, a quick look at the condition. The cables are all moldy and absolutely disgusting. But none of this stuff could be easily replaced. So I'm just gonna have to keep scrubbing until I get all that stuff off. The case is all rusty up here and on the back. But strangely enough, the rest of the case is pretty free from rust. So I guess I'll grab the wire wheel brush and see if I can clean this up. Actually, I noticed something at the back here. There are some leftovers from a blue sticker that says something bank. So apparently this IBM was doing some banking, and I guess I'm not surprised. These machines were crazy expensive back in the day. And the bank, they had all the money. I also noticed something here. On this sticker here it says 12/95. So this must be a very late machine. I think they ended the production in 95. I'll check and write something on the screen here. Okay, all the bits and pieces have been washed and cleaned. The case isn't perfect. It obviously still has some scuffs, but it's a million times better and clean enough to be enjoyable. And that's what's important. The case only had rust up on top here and at the back and around this grill here. I cleaned it up with a wire wheel brush and then applied a coat of primer, but only this repaired area here to keep it as original as possible. There were also a couple of minor spots elsewhere that I gave the same treatment. So the rust is gone, and this case is clean enough for me. Same thing with the lid here. I removed that nasty foam pad, removed all the rust and applied some primer, but only on this area that was rusty. So the first thing to go back in is the bracket for the cards. This piece is made of die-cast aluminium and was really badly corroded, but I managed to clean it up with some car polish. Apparently that worked perfectly. And this bit goes in back here, of course. And next we can install the bracket with the thumb screws. And next we can install the drive cage. And with the drive cage installed we can now move on and install the motherboard. I washed the motherboard and installed some more RAM to reach 128 megs. One of the screws, however, is underneath one of the RAM sticks, so I need to install that screw first. This board is absolutely massive. For size comparison, here is a regular socket 7 board. The IBM board is more than twice the size, and that's without the CPU complex. So you would have to add this card too for a fair comparison, which is pretty crazy. Anyways, I installed all the screws and that last RAM stick and a fresh coin cell. Next I installed the back panel and this thingy here. What this does is to connect the fan on the lid to the motherboard back here. By the way, if you want to see a more complete disassembly and reassembly, I will put a link in the description below and at the end of this video to the Model 95 XP restoration. And I'll be skipping quite quickly in this one, not to repeat myself. The back panel turned out really nice. It looks pretty much brand new. By the way, I checked that date of December 95, but I couldn't find anything specific. These machines were manufactured between roughly 1991 and 1995, but I couldn't find any specific dates. So then we have the weird fan installed on the lid. It was pretty rusty, so I had to disassemble it, remove all the rust from these pieces and applied some primer. The bearings on the fan sound and feel pretty terrible. So I'm going to add a drop of machine oil on each bearing and hopefully that helps. Okay, that was no fun. As with so many other things, it was easy to disassemble but pretty tricky to reassemble. It's held together with these tiny tabs here, a whole bunch of them all the way around here. And the tricky bit was of course to align everything. And oil made a huge difference. I had to use a little bit of force to turn it before I oiled it. Now it spins freely. There was a small sticker here that said something like, when this sticker is visible, the fan is correctly installed. So I guess this must be the correct way to install it. Okay, next we have the power supply. These two bits had some serious rust on them, so I had to use the wire wheel brush on the large polishing machine. And eventually I got it all off, and then I applied a coat of primer. This bit here had no rust on it, so I'm sure it's a good power supply, but it was absolutely horrible to disassemble. And my usual disclaimer, please don't mess around inside power supplies. Some of the caps here could be charged with mains voltage, even with the cord unplugged. That being said, this power supply was completely jam-packed with dust, but after a wash it looks pretty much brand new. And the good news is, nothing is leaking or bulging. This is, by the way, a 399.1 watts Delta power supply. That's very specific. Why not just write 400? But the date code here is interesting, week 45 of 1995. So it is indeed very late 1995 machine. The fan in the 95 XP was really noisy, so I decided to replace the fan and this power supply with the Nokia NFP12 Redux 900. And hopefully this machine will now be a bit more enjoyable for retro gaming. The fan connectors are different, and they were also reversed, but the pins inside the connector are identical. So I can just move the original connector to the Nokia fan and cut that extra yellow wire off. When reassembling the power supply, I decided to remove the thumb screw by removing the C-clip here, and that made it significantly easier to reassemble the power supply. So that's the way to go with these. I'm really surprised at how clean this machine is coming together. I really didn't think it would. Even this moldy, disgusting cable here looks pretty decent now. And we are almost ready for a test. But first we need to fix this diskette drive. So some Model 95s came with a drive that doesn't suffer from leaky caps, which is a rare exception for IBM PS2s. And unfortunately this is not one of those drives. This Mitsubishi has two electrolytic caps back here. But the good news is we caught this one on time, so they have not damaged the PCB yet. Some of the solder joints here are a bit dull, so they have started to leak, but just a tiny bit. Luckily this is an easy fix if you catch them early enough. I'll just grab them with the hot tweezers. That went bang! So you may want to wear some eye protection if you pull these off with the hot tweezers. Oh, I see, it was also glued to the board. Those red splashes are glue, so that's why it took a while to remove it. That gave it enough heat to pop. Let's see if this one is easier. No, this one is glued too. This normally takes 5 seconds, but I'm already at 15 or so. Well, it released the magic smoke, but at least it didn't pop. Next I'll add some flux. Sometimes that glue comes off with just heat. So I'll use a relatively large tip with a big blob of solder on and heat that glue up to see if it will come off. We can just leave it. It shouldn't really matter. No, this was a pretty stubborn glue. It's not coming off that easily. Let's add some more flux and some solder wick and start cleaning the pads. And I'll just leave that glue on the board. I don't want to stress the PCB with some sharp tool trying to scrape it off. I think it's better to just leave it on the board. And with the board cleaned up, I'll add a splash of solder on one of the pads. And then I'll add a brand new 100 microfarad 10 volt cap. Actually, I had to switch to a smaller tip because that was a really tight spot. This smaller cap here is a 22 micro 10 volt cap. Okay, we are finally ready for a test. Probably just a few minutes of video, but it obviously took days of cleaning to get here. Okay, here goes. And we're getting some checkpoints. The fan is blowing in the power supply and it's posting. Big old IBM splash screen. SurePath BIOS revision level 10. Diskette subsystem failure. Configuration not valid for system complex error. Time and date not set. Then we're getting some funny characters. And a super weird postcode. Okay, so something isn't quite right here. Okay, I borrowed the diskette drive from the 95 XP. Let's try again. We're getting the splash screen, but we're still getting a diskette subsystem failure. Then we're getting those weird characters. Oh crap, something is wrong with this machine. Okay. Move the floppy drive from the last to the first connector on the cable. Now it's actually reading. The display is showing 90 megahertz instead of those weird characters. Okay, awesome. It's booting to the ref disk. And we're obviously getting an error in here, but that's perfectly normal. So if you're new to all of this, the reference diskette here is sort of the way to get into BIOS on these machines. Okay, in that case I'll swap to the original drive and we'll see if it works. Here goes. It's going through the checkpoints. The drive made a noise. Configuration not valid. Time and date. Those two errors are expected. But it wasn't able to read from the reference diskette. Let's try with the cleaning disk. I'll run it a few times and make sure those heads are clean. The drive is clearly spinning and I can occasionally hear the head move. So it is at least somewhat working. Let's try with the ref disk again. Well, it moves the head, but it doesn't seem to find track 0. Well, in that case, let's try this. I placed a drop of machine oil on the worm shaft, and then I used some needle nose pliers to turn it. And in doing so, the heads moved to this position here. And then I connected it as drive B. Let's give this a try. That's strange. We're not getting anything on the screen now. Very strange indeed. Let's try without the drive. No, we're not getting anything on the screen anymore. Okay, I checked. This code here indicates that we may have an ECC error. So I'll remove the 2 sticks I added and we'll try again. And unfortunately, that didn't fix it. So it might be one of the original SIMs that came with this machine. I found the issue. I removed the CPU complex and added some deoxit on the edge connector. And apparently it was just a bad connection. So deoxit to the rescue once more. That stuff is expensive, but it just keeps paying for itself over and over again. Okay, so we're back at this test. I have the working drive from the 95XP as drive A. And the drive for this machine as drive B, with the heads moved down. Here goes. Okay, and I think the motor turned briefly on this drive too. Okay, so let's take out this error. Since I removed the battery, the system is not configured for the installed complex that we have here. That has to be done with a Type 4 ref disk. It's a simple process, sort of plug and play. Processor mismatch, run configuration program. Time and date not set. Okay, processor board error. Automatically configure the system. Yes. Set time and date first. Okay. He sets the time and date as he's told to. The automatic configuration program is running. Please wait. Luckily I've got some coffee and patience. Automatic configuration complete. System will restart. Okay, now it's counting up the RAM. Not too bad I removed the 2 sticks. But let's check and see how much we have. 96 megs, so my notes were correct. So we need to add 2 more 16 meg sticks to reach 128. Okay, so let's go to set configuration and view configuration. Okay, so here's our RAM. And it does recognize both diskette drives as 2.88 meg drives. These are, by the way, compatible with 1.44 meg diskettes too. And it does actually support a 3rd drive, which is pretty cool and very unusual for a PC. And here's our SVGA card. Okay, in that case, let's exit. And this time I'll boot to DOS diskette. From drive A, of course. Okay, I think we can skip the RAM test by hitting escape. Yeah, sure enough. Okay, and it boots to DOS. Awesome, so everything is working except for this drive. So let's type v colon. Okay, now it moved the heads. So heads are moving and it's trying to read, but it can't. Let's try to format the diskette in drive B. Invalid media or track 0 bad. Disk unusable. Well, this could actually be a bad diskette. So I'll start by swapping it for a new diskette. Okay, brand new green diskette in the drive. Let's hit yes. Okay. And it is actually formatting. So that may actually just have been a bad diskette. And the heads are moving. Everything is looking okay. Format complete. Well, the obvious next thing to do is to install this drive as drive A and see if it will boot from DOS. Here goes. Fingers crossed. So I wonder if this is the first IBM that came with a blue logo on black on the splash screen. I think it might be. Device configuration was changed. Okay, so it noticed that we removed one of the drives and it's asking for the ref disk. Oh no, it still can't read. Oh crap. Well, that probably means we have a head alignment issue. Oh crap, well I guess we'll do a head alignment next. So let's first prove that this is a head alignment issue before we start moving that head. And that's easy to do. So I have the working drive as drive A with a DOS diskette. And then I have the faulty drive as drive B. And I'm going to boot to DOS. And in DOS here we need to format B:, and make a system disk. So now it's formatting our new green diskette again. And also making it a system disk. Now let's reboot with the faulty drive connected as drive A with our freshly made boot diskette made with the faulty drive. Oh crap, I need to swap back to the working drive and run the ref disk to get rid of this error before we can do this test. I'll do it off camera. Okay, said and done. And we are back with the faulty drive as drive A and our green, freshly made system disk. And IBM has been configured to have only one drive now, so there shouldn't be an error now. Okay, the diskette drive is doing something. Oh, it boots. Okay, awesome. Well, in that case, this is definitely a head alignment issue. Well, I haven't done head alignment in one of my videos in many years, so I guess it was about time. Okay, so here's how it works. Inside the diskette there is a magnetic disk. The disk stores the information on tracks laid out all the way around the disk, with the track 0 as the first track out on the edge. Every time you turn the PC on, the heads will move to track 0, and then there is a track 0 sensor inside that will tell the heads to stop. So in the next step, when the machine tries to boot or read from the diskette, it will start reading from track 0 and then move inwards. Now here's the problem. If the track 0 sensor is misaligned and you turn the PC on, the heads will stop either slightly too early or slightly after they have reached track 0. That's where we run into a problem, because when you try to use the disk it will write or read information in between the tracks. That's why we were able to boot the machine from the disk made with our faulty drive, but we can't use that diskette in any other drive, and if we try to use a properly aligned diskette in our faulty drive, it won't work either. So what we need to do here is to align the track 0 sensor so that the heads will stop exactly at track 0. That will make it compatible again with any other diskette. On some other drives we have aligned before, the track 0 sensor has been on a small PCB. We would loosen up a screw and then move that small PCB back and forth until the heads were aligned. But this drive is quite different. The track 0 sensor is on one of the lower PCBs here. And then there's a small tab here that tells the sensor when the heads have reached track 0. One of the holes on this PCB is oval. So what we need to do is to keep the screw loose and then move the PCB back and forth like this until we have found track 0. So a bit different, but this method should apply to pretty much any floppy drive. except that we have to move a large PCB here, instead of a tiny PCB with just a track 0 sensor on. Okay, this could be a bit tricky, because when I move this PCB, it immediately goes back to its previous position when the screw here is loose. I'm going to have to lock the screw down for every single test. Well, no wonder we had to align the heads, since we had to remove that PCB completely to replace those leaky caps. But anyways, this was super easy. And as you can see, we can now read from both drives. It actually went so quickly, I didn't even have time to turn the camera on. So all I did was to loosen up these two screws here. And then I moved this PCB just a tiny bit, less than a millimeter. And then I tried to read from drive B. And after just 2 attempts, the drive is now working. But now that I've been playing around with this drive, this design actually sucks pretty badly. So when you connect and disconnect the ribbon cable up here, you apply quite a lot of force on this PCB. And the only thing that's holding it in place are these two tiny screws in oval holes. Well, then we know, if you ever repair one of these drives, you will have to align track 0, since you will have to remove this PCB. But as I just mentioned, this only takes a few seconds to do. Perhaps I should mention one more thing. Before I start aligning that PCB, I make small marks. That way it's much easier to know in which direction I have pushed it and how much. Okay, next I did a couple of reboots to DOS. And then I loaded up a couple of games, just to make sure that the drive reads reliably. And it does. I should also mention that you can do this with the scope. There are some test points on one of the PCBs on the diskette drive. But personally I prefer this method because it only takes a few seconds. I should also mention, if you only have one drive, then the procedure will be the same, but you would have to turn the machine off and then try to boot after each time you have moved that PCB. And here's another game loaded directly from the diskette drive. As you can see, no issues whatsoever. So this machine is now fully restored. So let's move on and do some upgrades. The first and most essential upgrade is of course going to be a fast and silent hard drive. Unfortunately, it's been a few years since I found a SCSI drive in good condition on eBay. This drive has matching dates, so I cleaned it and I'm going to leave it in the machine. But I'm not going to use it, because these are really noisy little buggers. And that brings us to the sponsor of this video, PCB. Let's have a look inside this box and see what they sent us this time. So these are GB SCSI 2 cards. So these cards provide up to 18 megs per second read and 11 megs per second write speeds. So this should be a pretty good match for the mighty 95A. So the first obvious difference here is that these cards are much smaller. These guys are about the same size of a hard drive for a laptop. So I guess you can use them for a laptop too. And as always, the PCB looks amazing. Presumably to make them much smaller, these cards don't use a Raspberry Pi module, like the other two options we have tried before. And instead, these guys have the RP2350 chip soldered directly to the board. So this should be not just a much smaller card, but also a much more elegant solution. I have placed one thermocoupler right underneath the chip, and a second thermocoupler as close to the chip as possible on top of the PCB. And I'm gonna go quite high with this one. So I've set the temperature to 150. Okay, and next I'll apply some flux on the pads. I might as well put some on the chip too. You can never have too much flux. And then I'm going to put some solder on all the pads. Well, that's a bit too much. Let's make it a bit less. Yeah, that should be perfect. Unminding the notch. We can put the chip on the pads. The pads for this chip are incredibly small, so I'm going to spend some time to make sure it's properly aligned. Okay, chip has been aligned, so without using the nozzle, I'm going to heat the PCB up to about 200 C. Oh crap, too much airflow. Okay, chip realigned. Let's try that again. I have the rework station set to 300C and airflow is about 40%. Now I'm going to heat the board up to about 200C. If you don't have a preheater, you can use a rework station to heat up the board too, especially on a small PCB like this. So this should take about 1 minute, so I'll skip ahead here. Okay, so I actually had to realign the chip again. Now it has reached roughly 180C. So now I'm just going to keep it at this temperature for about 1 minute. I'll lower the airflow to 30% to prevent the chip from moving. And this seems to be working. So this is not the proper way to do this, but this is what I can do with the gear I have. I use this method to repair my MacBook Pro and it's still working. So if it's good enough for a laptop, I'm sure it's good enough for this card too. Okay, board has cooled down significantly, but I left it at 50C and made sure the chip is firmly attached. Next I'll apply some fresh flux. Then I'm going to use a tiny chisel tip to add some more solder to all the pads to make sure they have enough and make a good connection. And the final step is going to be to check for bridges. The chip probably looks huge on camera because I have quite a lot of magnification here. But this thing is tiny, so I'm gonna have to check for bridges with a microscope. Okay, heat turned off completely. Time to scoop up the flux. So I think the rest of the build is going to be very similar to the blue SCSI build, because this chip is the main difference. So if you want to see a more complete build on a very similar card, I'll put a link at the end of this video and in the description below to the blue SCSI build. And I'll skip ahead here unless something interesting happens. And unfortunately, this card has tons of 0603s. I hate those little buggers. Well, I'm not gonna lie, that was a pain with all those 0603 components. I don't understand why they are so frequently used on hobbyist projects like this. Those damn things are smaller than a grain of sand. Well, if I can stop whining here, the build was quite similar to building one of these blue SCSI cards. And the main difference here is that this board uses the chip soldered directly to the board instead of having this large module here, which I think is great. Another advantage is that this card has USB-C instead of that old micro USB port. So that's a bonus too. It also uses a micro SD card instead of these regular larger cards. I went through my stash and I also found a suitable controller. So this is an IBM SCSI 2 Corvette card and it can do 20 megs per second both ways. So this should be a pretty perfect match. I placed a copy of the Oscilloscope firmware on the SD card and an ISO file with DOS622 installed. So we're ready for tests. Okay, I decided to test the controller first with the original hard drive, and the damn thing actually works. Too bad it's too noisy for retro gaming. And that hard drive actually had Windows NT 4 installed with some really weird software. I think this thing here is for translating between Latin and German. That's pretty unusual. Unfortunately, I don't speak German or Latin, so not very useful for me. But now we know the controller is working, so we can move on and test the GB SCSI. I noticed that the CPU complex got really toasty when running the machine with the lid open, because it has that weird fan installed on the lid. So I put a couple of fans here while we mess around with this machine, so we don't fry that precious card. And I also forgot to install these guys. They are for cable management, were installed up here with some double-sided sticky tape. It's no fun to watch, so I'll install them later off camera. If I remember correctly, this card will work without external power in some but not all machines. So let's see if the mighty 95XP has enough power through the SCSI cable. Okay, here goes. The image file on that SD card has been tested on the PS2 model 50, I think. I can't quite remember. but that should be a working DOS installation. Well, we've got a flashing cursor, but then we're getting a SCSI disk drive error. Okay, so that sucks. Okay, in that case, let's try with external power. And it boots! Awesome! So all that was needed was external power. Okay, cool. So now we have really fast and completely silent storage. Well, I hadn't actually considered how to install that card in this machine. But luckily I had ordered some 2.5" to 3.5" drive bay adapters for another project. So we can snatch it, and I'll just order one more. Well, that's almost perfect. But the holes were too small on the PCB, so I had to enlarge them to be able to use regular PC screws and standoffs. And only one set of screws line up with the holes on the PCB. I could easily just drill a second set of holes here, but I'm not going to bother, at least not right now. Maybe I'll fix it later, and I'll just install it with these two standoffs. I decided to use the standoffs because now I can access the SD card, without this bit here being in the way. Yeah, the PCB sits quite firmly in here. No need to install screws in all 4 standoffs. This is sufficient. And here it is installed in the machine. It's pretty neat and tidy. The front panel is very easy to remove on these machines, giving very good access to the SD card here. So I'm going to call this upgrade a success, at least for now. More on this later in the video. But first, let's take care of this empty bay here and install a CD-ROM drive. The TEC drive from 1996 that came with this machine is somewhat unusual. Instead of having the door on the sled here, it first opens up a door and then ejects the sled through the opening. So that's the first, but it's not a matching drive for this machine. So I'll order a set of caps for it, and then we'll use it in some period correct clone in the future. Unfortunately, I don't have a matching PS2 drive for this machine, but we still have this broken loaner here. We have recapped it in a previous video, but unfortunately it didn't fix the issue. Since then I have been messing around with it, and I have been able to pinpoint the issue to the PCB. So we know for sure that the heads and all the mechanics are good in this drive, but something is still wrong with this PCB. So I think we should make a second attempt and see if we can find the fault. Okay, we're off to a good start here. My main suspect right now is bit rot. But when I was messing around with the socket here, the thing is loose. So there's something wrong with the socket. So probably not bit rot. This could be the damaged socket here. When I had a look at the socket here, I can't see anything obviously wrong, but it does look a bit bent out of shape. So perhaps the plastics haven't aged well. And here's our BIOS chip. Well, since one of my suspects was bit rot, I ordered one of these adapters so we could read and write to the EEPROM. And since we have the chip out, we might as well read the contents. The bits on an EEPROM don't last forever, so it's always good to have a copy. Oh crap. This adapter here came with these wide pins, and I think I damaged my socket in the TL866 with pin headers just like these. So before we can use it, we have to replace them. Okay, so apparently the socket doesn't fit directly in the TL866. So first it's soldered to this PCB with a set of pin headers. And then it has a second PCB with a second set of pin headers, just so it would fit the TL866. So I obviously can't reach in here to desolder these pin headers. So I'm gonna have to desolder this row of pin headers on both sides, and then replace these pin headers, and then put this PCB back on. So that's quite a lot of work, just to read an EEPROM. But I think this adapter is going to be very useful for many other projects. So it's just gonna have to be worth it. It's not going to be fun to watch though. So I'll skip ahead here. Well, that went kind of okay. It was a bit of a massacre. The pins to the second PCB were easy to desolder, but the pins going down to the EEPROM programmer, they were cut flush for some reason, so they were a pain to remove. Okay, I reassembled the adapter, and now this adapter has skinny machine pin headers. Now, I can't be sure These thick pin headers killed my TL866. But something did kill that socket. Oh no, something is wrong here. The chip doesn't fit. Oh crap, what is going on here? It's not a standard chip. It's supposed to be 7.5 millimeters. This is some kind of special. Oh crap. Well, I obviously don't have an adapter for a weird and non-standard chip. But maybe if I push down on the holder like this, and then push on it firmly with my finger, while I read the contents. Let's give that a try. It might work. And unfortunately, that didn't work at all. It wouldn't make connection to even half of the pins. Well, I went through all my adapters, but unfortunately nothing fits. So I don't really have a way of reading that EEPROM. We're just gonna have to move on. Okay, so what we actually need to do to try to fix this drive is to get rid of this damaged socket. Now there's obviously no way I can find one of these. But what we can do is to remove it and see if we can solder the chip directly to the board. So I'll add some flux to all the pins to keep the temperature down. I'll add some chip quick to all the pins. This is going to lower the temperature required to remove the socket. Okay, there's actually a rubber band here. Probably designed to be some kind of seal. So I'll move it out of the way. It probably doesn't like all that heat. Now let's add some chip quick to this side too. I'll move the sticker too. It will probably melt when we use the rework station. Oh crap, I forgot to turn the camera on. Okay, so I just applied some heat with the rework station on both sides. And it only took 10 seconds or so. And the socket came off. Now of course we need to remove all that chip quick. Making sure the pads are perfectly clean from this stuff. We don't want to mix this stuff in with a regular solder, because that will make for really weak solder joints. Okay, much better, but not quite clean enough. So I'll add some more flux and clean some more. Now let's hope that these pads are wide enough to take the chip directly and not just the socket. Otherwise we're going to have to do a really ugly bodge here and connect all the pins on one side manually. So I really hope we won't need to. So I'll remove this flux and we'll check the width of that chip. Okay, flux cleaned up. Oh, I think it just about reaches the pads. I think this might work, but the chip legs will only sit 0.5 millimeter on each pad. But that should be enough for this to work. Okay, great, so I'll align the chip. Okay, I aligned the chip and my estimation was pretty much spot on. Each pin sits about 0.5 millimeter on each pad. But that should be enough to make a connection. So I'll just solder all the pins here. Now you may think I should install a new socket here. And I gladly would. But where the heck do you find a non-standard socket like this? Okay, I'm getting a couple of bridges here. So I'll add some flux later and remove them. Okay, and here's the result. So not ideal, but this is good enough. That chip is making a good connection to the PCB, and that's what matters. Okay, I reinstalled the PCB in the drive. Time for a test. And I'm going to test it on the 95XP here, because it has a CD-ROM drive installed. And this machine is freshly tested. Okay, the LED lit up. Okay, and we're getting an error 112701U. I heard a clicking noise from the CD-ROM drive. Okay, but it's counting up the RAM, so it's not stuck. Okay, it boosted the ref disk. SCSI adapter error. An error occurred while testing the SCSI adapter. Well, that's a bit odd. And we've got an IML error. I was expecting a SCSI device error. Let's go to set configuration. And on the display here we've got 112701U. And in here we can go to set and view SCSI devices. Okay, and unfortunately that CD-ROM drive is not showing up here. It should have been in the list here. Oh crap. Let's try to run the automatic configuration. And the CD-ROM drive made a clicky noise again. Automatic configuration complete. So let's exit and reboot. Okay, and it's actually the head moving up that makes that clicky noise. And we'll still have the error. And the head's moved up and down again in the drive, so it is trying to do something. And we'll still have a SCSI adapter error. So not only is it not working, it's also causing the controller to fail. So it has a pretty severe issue. And it also gives an IML error, which is super weird and unexpected. But let's update the system program. This will recreate the IML, which is the BIOS setting stored on the hard drive. The system does not support having a system partition on the hard disk. Wow, that's super weird. So unfortunately this drive is doing some pretty severe shenanigans with the SCSI controller in this machine. Okay, I disconnected the SCSI drive and the IML error went away and the machine works perfectly. So unfortunately this drive is in a pretty bad state. Well, in that case I'll order some kind of adapter and we'll try to flash that BIOS in a future video. I glued all 4 tabs back on the front panel here and reinforced them with some baking soda. And unfortunately just a spare blank instead of a CD-ROM drive. I'm not sure why we got that error earlier, because I decided to test that card without external power. And it's actually working perfectly without any errors. I'm gonna have to do more tests to be sure that it actually works without external power. But at the moment it actually does. Well, the restoration was really successful. I'm really surprised at how this machine cleaned up. I really didn't think it would. Too bad about that CD-ROM though. As for the GB SCSI card, things went a bit weird. I ordered these PCBs months ago, but when I checked now, the project has actually been abandoned. But progress has been done elsewhere, so I'm actually going to order more PCBs. We're gonna try something even faster. And the main project for this machine is to overclock the crap out of it. Of course it is. Before you leave, like, subscribe and leave a comment. And consider joining me on Patreon. And that's all I had for you today, and I'll see you guys again next week.